Welcome all of you in Dwarka education. Today we again solve the problem on differentiation. We take a simple problem xy plus x की power e की power minus y plus y e की power x is equal to x की power 2. Now solve this equation. Differentiation both sides by dy by with respect to x. Then x into dy by dx. We use u and v product formula and plus y. Differentiation of x is equal to 1. We put 1 plus x into differentiation of e to power minus y minus dy by dx plus e is y plus e to power x plus e to power x into dy by dx is equal to 2 to power x. This is the differentiation, but now we collect dy by dx one side, then dy by dx x minus x की power e minus y plus e की power x is equal to 2 की power x. This goes other side, change the sign, minus y. Now we find out the dy by dx. Differentiation of the equation with respect to x is equal to 2 to power x minus y e to power x minus y and x minus x की power into e की power minus y plus ex. This is the differentiation of this equation. Very easy, and you should try yourself and you can easily solve this problem. Now I say again that x into dy by dx plus y into dx by dx plus x into differentiation of e to power minus y plus e to power minus y differentiation of dx by dx and y differentiation of e to power x over dx and differentiation of x over x square. We can see this. Now this is the solution of this equation, and with the help of this solution we easily solve this above equation. And never forget that in all these steps we use u into v product formula, u into v product formula. And just repeat again, differentiation of y, differentiation of x, this is equal to 1, differentiation of y, then we can solve this problem easily. Now take the simple problem on the differentiation. This is the equation of the circle. plus plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is the equation of the circle, and we find out the differentiation of this equation. Don't worry, very easy questions, but here we use u into v product formula, and others are single variables, and in the single variable we can solve easily. First of all, differentiation of x square, यानी 2a की power x plus 2h is common into x into dy by dx plus y. Difference of y into 1, this is equal to, no need to write 1, we know the differentiation of x is 1. And differentiation of this is equal to 2 की power 2b into y dy by dx plus 2g plus 2f dy by dx. Differentiation of 0 is equal to 0, and we can write that this is equal to 0. Now just solve this little. Two ax plus 2hx dy by dx plus 2hy plus 2by dy by dx plus 2g plus 2f dy by dx is equal to 0. And take dy by dx common from this dy by dx terms. Now dy by dx into 2hx plus 2by plus 2f. This will be equal to minus bracket shuru 2ax plus 2by plus 2g, and now dy by dx is equal to minus 2ax plus 2by plus 2g whole divided by 2hx plus 2by plus 2f. We take common from this both. 2 is common, minus 2 oblique ax plus by plus g whole oblique 2hx plus 2b plus 2 common from this all, and this 2 is to cancel, and this is the result of the dy by dx. So, pen sakte pen please. Ink. Next. And just again, I am told you that take attention about this question. We take the mistakes in this question, mainly use of sign minus, and this is the important. When we are going to change minus, this minus forget the students, and this is compulsory to understand this point minus. Many students forget this minus, and your numerical became wrong. And take attention. Next time I tell you once again, differentiation of this equation. In this equation we use UV formula, otherwise in single units we take the differentiation only dy by dx with single variables, and easily we solve this calculation. But students should take care of this minus. This minus should be important, otherwise question will be wrong. Any questions those students could not solve the problem, they can ask on YouTube for your solution. I will take in my class and solve the problem. Now I take a problem when we put in exercise 5.11 and we take a question just a minute. I take the next one. Tan inverse x to the power 1 oblique 3 minus a to the power 1 oblique 3, and there is plus, and x to the power 1 oblique 3 minus 1 minus x to the power 1 oblique 3 into a to the power 1 oblique 3. As like this problem, first we should suppose and putting the with differentiation was putting the an other variable. Let x to the power 1 oblique 3 is equal to tangent theta under root tangent theta. Then we put this in tangent theta here, tan inverse tangent theta, and a to the power 1 oblique 3 we put tangent beta. This is constant, but we put here tangent theta and here tangent beta, and this equation became tangent theta into tangent beta. First of all, this is very important and tricky questions. These are known as tricky questions, and in this question we have used x to the power 3, x to the power 1 oblique 3 is equal to tangent theta, and this is the main trick. We also use a to the power 1 oblique 3 is equal to tangent beta, and in this question this formula became tan inverse tangent theta plus beta, and this became theta plus beta. Here beta is a constant and whose differentiation is equal to 0. Very important. There is tangent beta is constant and its differentiation is 0. Now y is equal to theta. and here we value of the theta. Find the value of theta. Theta is equal to tan inverse x to the power 1 oblique 3. And put here tan x to the power 1 oblique 3. And we have find the differentiation of this. Sorry, this is tan inverse. Noted that this became tan inverse. This became the tan inverse x to the power 1 oblique 3. And by this equation, we solve this by using the formula. This is equal to now 1 oblique 1 plus x to the power 2, and differentiation of x to the power 3 is equal to 1 oblique 3 into x to the power minus 2 oblique 3. This is differentiation of x to the power 1 oblique 3. And now we can solve that 1 plus 3, 1 oblique 3 is equal to 1 oblique 1 plus x to the power 2 oblique 3 into, this became down minus power, this you can write x to the power 2 oblique 3. And this is the solution. We can write like this: 1 plus 2 to the power x to the power 2 oblique 3 into x to the power 2 oblique 3. This is the solution. And I repeat this again, that put x to the power 1 oblique 3 is equal to tangent theta, and a to the power 1 oblique 3 is equal to tangent beta. And this formula became tangent alpha theta plus beta. This became tangent theta plus beta, and we find out the differentiation of tan inverse 1 oblique x, because theta is equal to tan inverse 1 oblique 3. And this is the solution of this problem. And those students join now, they take attention about this next question. We will solve. First, when this type of question where plus and minus with product of this and this, we put this is equal to tangent theta and this is equal to tangent beta, and we provide the formula of tangent theta plus beta in tangent a plus b का यहाँ पे tangent a plus b का formula यूज किया गया, and this can be solved easily. Only one trick can solve the equation very easy, and without trick it is impossible to solve this question. Now, tan inverse x oblique no, so next question actually not working this work. x oblique a square minus x square का अंडर रूट. Now, in this chapter, in this question, there is also a trick. The trick is this, that we prove this. First of all, this is the square in the equation. When the square is there, when you use x is equal to sine theta or cos theta, and we have this is equal to sine theta. But sine theta no need, but there is also a, so we should prove that a is common. To take common from this equation, so we put x is equal to a sine theta, and put this value here, tan inverse a sine theta oblique a square minus a square sine square theta. Why we take sine square sine theta here? If we take it here cos square theta, then it will also be solved also. But we remove the tangent theta. But we can also use that x is equal to a cos theta. There is no 1 over. We can put x is equal to a cos x. What will happen then? Then a की power cos x minus. But this we can solve by this also, but we use only a sin theta. Next, we use only a sin theta. Then this problem became, this is equal to a sin theta tan inverse a sin theta oblique a square common, a common आ गया तो अंडर रूट 1 माइनस sin square theta. 1 minus sin square, first formula of the trigonometry. This is equal to cos theta, and this is equal to tan inverse a sin theta oblique a cos theta. And it is very simple. It is became tangent inverse tangent theta, and now value of theta became sine inverse x oblique down in this equal to theta is equal to x oblique a sine inverse x oblique a. Now we find this is equal to theta, and theta value is equal to this, and sine inverse x oblique a dy by dx is equal to 1 oblique 1 minus x square oblique a square. This is, and under root this also a, put here a, then this is equal to 1 oblique a square minus x square, and differentiation of x oblique a, this is equal to 1 oblique a. This a is equal to here. We write this a is equal to differentiation of x oblique a. This is equal to 1 oblique a, and this became this under root a. Then this became whole under root, and we write down this, take this a square common, b is equal to 1 a oblique a under root a square minus x square, and dy by dx is equal to 1 oblique a square minus x square under root. This is the solution of this problem. Very easy. Only trick, use a sin theta is equal to x. And this will be our last problem in this class. Due to some technical problem, we could not increase this class more. And thanks to joining us. And tomorrow we will join again with new questions, with tricky questions of the differentiation.